This is Jenny Chen. I'm just going to wait for the attendees to trickle in here. Audience number one has stepped in. So I'm just going to talk a little bit about 3D heels, and I've been talking about this for, I guess, many years, the same intro, just the 3 missions for us. Number 1 mission is we want to educate people in the world about 3D printing and how it can empower healthcare. So we want to feature all the healthcare applications and educate people. And number 2 is to create a network of innovators and entrepreneurs. So that's our main mission. Today's topic is a very popular topic in our space, which is 3D printed prosthetics and orthotics. And
a lot of access to prosthetic care. And I can remember vividly, it was around the 2014 mark, where I had a colleague of mine say, Brent, I love what you're doing. I think what you're doing is great, but reality is how much impact we've is allowing clinicians to scale the fabrication side of things. So just a little bit of history about the fabrication. When you're doing stuff very manually, you are taking a cast. So on the very left-hand side of the screen, you take a cast, 75.36. Well within what we need. And are there techniques and all that stuff to make things a little better? Sure. But these in the world, it's who is wearing these. We can test till we're blue in the face, but until we put it on patients and get their feedback, as long as it's safe, we don't know. And so this is a very, it's a great testimonial from now my friend Dana, who's been wearing this style prosthesis now for almost 5 years.
She's super excited. Yeah.
To us, in the traditional fabrication side of things, this was not possible in traditional fabrication. And that's what I'm so excited about, is you have some extreme pressures, especially if you're trying to correct something, and you just need eyeballs to check for skin integrity to make sure that you don't have skin breakdown. And so a lot of times what we try to do is partner with local physical therapists or nurses. So if we're going to do an orthotic device,
I don't think I've seen one other founder who is also amputee himself and then started a company in the space, which I feel is more, touching, and then just like you can really have the empathy for the people who are suffering. So Christopher, please go ahead and start your presentation. Thank you so much for joining us today.
And that's a topic we can come back to, because I think it is a driver in this space when you have personal experience that we can come back to. So I will give a bit of an introduction to ProsFit and what we're calling our 3D solution, digital, distributed, and disruptive. I know the point of today is not sales, so we'll make it more of a general. We are a mission-driven company. We understood, based on my experience, we want to provide personal mobility solutions, and where we have the experience first is amputees, and this is where we're going to start. Challenging in a challenging environment also for the professional. So it was based on that experience of just continuously getting quite poor fitting prosthetics in the first few years that we decided that we must be able to change the game. So in 2013, we founded ProsFit with the vision, a world where innovation provides limb wear as a choice of affordable, reliable, and desirable prosthetic products and services. And here you can see a few of our testimonials. Also, I agree with Brent. In the end, what really matters is how is someone's experience using it? Are they able to go out and live their life, regain their mobility, and achieve their quality of life? So before we speak about some of these details, let's look at a more statistical level. And this is a challenge in prosthetics. So according to the World Health Organization, WHO, there are about 1 billion people in the world today who need assistive technology, right? And that includes prosthetics and orthotics, wheelchairs, eyewear, hearing aids, learning devices, etc. So getting access to a prosthesis is critical for any amputee, right? Critical for mobility, for good health, quality of life. So ProsFit has the answer. So we developed an innovative digital platform for the design and manufacture of custom-made sockets at scale. Work 100% offline, because as we discovered even at our clinical investigation in the NHS, and data-driven solution is something that we've developed to turn also an art into the extent that we can into a science. And there was just a massive amount of resistance in the industry. And I think that that's a shared experience that a lot of us have had introducing new solutions in this field. So to provide some independence and objectivity, we realized, yes, we have to complete a clinical investigation and regulate these as medical devices. So we did that with the NHS in 2015 at one of the largest NHS centres, in a very well fine-tuned over the course of time socket that they were already happy with. So the results were really impressive, and we decided, so here, having a max of different rigidity and flexibility in different areas, a ProstFit Natural also, again, as a user, you get to the ability question also, some adjustable solutions. And I agree also with everything Brent said on that topic, and it's an important one also that we can come back to. We understood with that we're not just a socket company, and there are various situations where people need the full prosthesis, and that also helps with the scalability. And so we developed a solution. Obviously, we're very highly quality focused, and as a user of all these devices, and I should say also as someone with applied mathematics and quality management system, as a representation of that. So to date, we have fitted over 700 prosthetics around the world, or our customers, I should say, have. So, and related to that energy efficiency, with little use of check sockets and all the other steps, we're talking about 90% less energy use over the life cycle of providing the prosthesis. We all are here of pushing 3D printing, improving healthcare for user outcomes. It is nice that we've had recognition and awards in this space. And group, we are dealing with all kinds of challenges, including aging populations, changes in lifestyle. This is going to become more and more of an issue. So I think that it's being recognized, and that's why we've, in part, why we've had the great opportunity to work with big companies such as Toyota, HP, BASF, Oracle. Coming back to that, I think, in our spirit, and something that I hope will also be fertile ground for conversation moving forward, collaborative innovation. How do we get deployment? These digital solutions really change the game in terms of how you deploy prosthetics care and provision. And I think that this is a really critical one and topic that is worth coming back to, because, well, isn't it ridiculous that someone with no legs has to travel to a clinic to get prosthetics, right? 60 prosthetics for 42 amputees, because there was some scientific double-blind elements in there. Again, and I think this is true of ProstFit, but also the wider conversation that we're having here, improved user outcomes, clinical productivity, and as well. We're now creating new end-user focused channels for outreach to all amputees. So not just within the existing system, but working with players who would like to go and create new channels to add some of the scalability where it hasn't been able to exist up until this point. We're also doing some quite interesting work in terms of collecting all sorts of scientific data, is changing a lot of these variables for how a prosthesis is aligned, is how a socket is fit. And ABB were very generous to donate this large robot that we are collecting a lot of very interesting data on. Very interesting to compare that data.
I don't even know what that is.
So I believe what he's talking about is something similar to what the Mark Forge does, which puts down the carbon fiber filament all in one pass. So here's the thing that, and I think Chris touched on it and I touched on it, we're trying to go from rigid to flexible. We're living human beings, and Chris can say he would much rather have a flexible device than a rigid device. So we're trying to go away from carbon fiber, rigid materials, and more to compliant materials.
Completely agree. Yeah, that's one of those things that has been a night and day experience for, and probably a shared experience for all of us, with whereas, as soon as you walk on it and there's that level of compliance and it feels like it's integrated to your body, you realize that actually the traditional prosthesis you had just felt like you put your leg in a bucket. necessarily tick all the boxes.
Correct, but you're going to be so rigid that you're not going to have that sort of delamination. And so typically, like with the March Forward, you also have some carbon, like chopped carbon almost in there. So you have some what's it called, entanglement and that sort of thing, layer to layer. So it definitely is stronger, but we're not looking for stronger, right? We're looking for compliant, comfort, that sort of thing.
But I just want to talk a little bit more about Go Engineer here. Go Engineer, we have all kinds of printers for Stratuses with multiple materials. We also have scanners. We also sell scanners. So the scanners that Brent and Chris were talking about to scan the body, we also have those solutions here. We have all kinds of solutions at SOLIDWORKS, including 3D Experience. So Go Engineer I was really grateful for Go Engineer to be able to print and to be able to help us out with this project. Now, what project am I talking about? Link. I got started on this project because I was asked to join a design project. It was a international. It was a project to redesign a prosthetic hand. This specific prosthetic hand. At the top, we are an American volunteer. I do this fully volunteer. This is all volunteer project. I'm just passionate about design and kind of the human aspect of it. So that's how we got involved in this. We were as part of a team to recreate this hand and make it more anthropomorphous, make it more human-like, redesign it with the humanity in mind. And so we took this idea and we said, well, how can we simplify the mechanics of a hand? And so we came up with this. Shake with my buddy here. We designed the triple finger so that it's able to actually grip onto, we can grip onto things, and that way we can, if I'm riding a bike, I can grip onto that bike and move it. Again, purely mechanical, so less moving parts, less easy to put together on site using standard tools, and it's have less items on your bill of materials, hopefully reducing that cost when we go to production and we have more and we do more field testing. Right now, we are still in the prototyping phase and we're still working out a couple kinks inside of this here. Now, they had talked earlier about multiple materials and compliant materials. That's what makes this thumb so amazing. The thumb is printed, Go Engineer printed this thumb and in our amazing J850 material, which has two different materials. So this is digital ABS. It's a rigid material, and then molecularly fused to a flexible material here, and that's going to allow me. But yeah, so this is the we also have a silicon overmold that we're going to put on the triple finger, because most folks in the developing world have access to cell phones, should be able to touch their cell phone. So again, one of the really important things for us in this design was the human aspect on the 3D Experience platform to create this organic shape for the fingers, right? And in fact, we actually took that NASA study, we put it in the background, and we shaped the fingers around to give them that very realistic 3D printing is at the point we're at right now, where we're able to prototype, and we're continuing to prototype and work out some kinks here before we get this into mass production. So you guys got this very nice sneak peek.
Using it. Thank you. So
Thank you.
Thank you, Jacob. Awesome presentation. Next presenter is Professor Jorge Zuniga from University of Nebraska. I've heard many talks from him in the past, always enjoyed it. And he's been doing this, I would say, ever since the origin of 3D printed hand, because he co-founded Enable movement back in the days.
So as Jenny said, we have been working in 3D printing, even upper limb prosthetic devices since 2012. I think we were one of the first teams to kind of do that. Incubators and put prosthetic hands, and you're going to find, about 50 something different types of prosthetic hands. So devices and material for additive manufacturing or 3D printing. So material that's that you can develop multiple things in space is very, very important. So we are working with the 3D printing team of the Marshall Space Flight Center in order to impart, believe it or not. That's cool. I wanted to share it. Fine, but it's not the exciting part, because the exciting part is the research we have with our fitness research. And since we have been doing this since 2012, it was very easy for us to accomplish this. So I want you to focus on these children and how intense they are working, because we're trying to, I'm a researcher, right? So we're trying to study how their brain adapt to this new prosthetic devices. And you see one of our designs, a lot of emphasis on that. Back in 2014, when we were making these prosthetic hands, and it was all over the news and blah, 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 with the collaboration with Enable, at the literature, I talked to surgeons, I talked to neurophysiologists, from all over the place. Nobody have ever looked at this. And what we did, we said, all right, guess what, children, we're going to give you a prosthesis. You're going to help us, and you're going to put a little cap in your head so we can understand how you're doing things, because now it's contralateral. So now we're in a situation in which 3D printed prostheses are allowing us to understand how children, use this. Is that when we did brain scanning of the children using this prosthesis, we compare, once we did like an upper limb prosthetic home intervention with these children, we found the following. Look at this picture here. This is the premotor cortex. The premotor cortex is in charge of very complex upper limb tasks. They use it. They learn at a way faster rate than a child that does have the two limbs, which to me is just fascinating. I was, as you can see in my slide, I presented this in the American Academy of Orthotics and Prosthetics. I presented this all over. Back in the day, I did talk a little bit in Johns Hopkins, and so I'm talking all over about this because it's very unknown. But this was super difficult 5 years, 10 years ago, because you needed a very sophisticated prosthetic arm, the ones that we needed to do experiments with cyborgs, with intersection of humans and robotics, like that. But now we partner with Innovative Prosthetics and Orthotics here from Omaha, Nebraska. We partner with a surgeon.
Thank you so much, Professor. The brain prosthetics connection is like my favorite subject, and I'm so grateful that you're doing research in this space. I was actually looking up a paper talking about children who play music, or interview with us. So this is certainly a very passionate area for you as an individual and also as a scientist.
He printed, and Jeff Aronstone from Create Prosthetics created the socket portion of it for her at that time, traditionally. And so that was her first device. You can see, she's had several devices since then. You can see my buddy Joe Fairley over here, and the local Haitian prosthetist, Cindy Laurent, here working on so I know there's a lot of people, that may be tuning in that don't have necessarily a background in this area. So I'll just, give a little explanation so we're all on the same page as I move forward. So my research area is really on improving transhumeral prosthetic socket design for use in low resource areas, specifically Haiti initially, but the hope is to scale prosthetic device extension. And what the socket is, it's really that critical interface between the person's body and the device, and it's meant to stabilize the prosthetic device onto the body, provide utility. In other words, when a person moves their arm, the residual limb, the device also moves with it. It should be comfortable, so people that finally get access to one actually want to wear it and don't abandon it. It's uneven pressure about the limb. Now with these CRS style sockets, the pros there are people report that they have greater control over their prosthesis with it, that there's less sweating, which makes sense because there's basically holes in it, so there's air getting there. There's less slippage, so they're not twisting around within the socket, it's staying in one place, and the pressure is more evenly distributed across the bone. However, distal tip of the humerus and near the axilla or the armpit, using that traditional style socket. And that's not what we want. We want to distribute the load, the pressure, evenly across the bone if we can. We want to also that where the socket was putting pressure on the soft tissue would be where the, where that, tissue damage would occur. But it wasn't. And he realized that it was because of the fact that there was basically this area of pressure where the socket was touching the body, and then right outside of that area of pressure, just directly next to it, was an area where there was so we did some preliminary compression testing on just 2 initial lattice unit cell types. So you can see that on the right. So then we, with those samples, we did a focused printability studies. On those, we tested a few different printing processes, a few different materials, changing some of the factors of each of these lattice structures to see how that would work out for printability. We want them to be printable. That's kind of more important initially than if they can actually service these compression and release areas. That would come afterwards. So we did end up finding 7 lattice unit cell types that we are now taking back into compression studies. Oh, I could field that if nobody else wants to jump in on that. Sure. So yeah, you can use injection molding. I mean, the benefit of 3D printing is essentially, not having that huge, I guess,
hybrid. So if I need, like for our project, we want to go to injection molding for mass production to make each of the components cheaper, right? But there's also a great use case for some of the folks on here talking about custom design. Which of those custom designs is going to need to be custom additive manufactured? And then the benefit with Jade for having lattice structure, well, 3D printing additive is one of the best ways to make a lattice structure like that. I mean, it's almost impossible to subtractive manufacture something like that. A lot of things to consider.
Christopher, what your thought on this?
Yeah, completely agree. I think if it's custom made, additive manufacturing is the perfect technology for it. And whether that is to make the device itself or to use it for injection molding, the same applies.
We have, we have our SolidWorks topology, but you can just go to goengineer.com, type in those questions, and we have a ton of answers right there on our webpage. And you can see, we have technology for topology optimization, lattice structures. And so really just start with a solid